Okay, we are on lesson 3, which is found on page 33. On the warm-up here, it's going to help us out. When it says determine the reciprocal, that means flip it. Keep the sign and flip it. Just kind of activating some of your prior knowledge there. Now, when I do that for number 4 here, I have to throw on a constraint where C cannot be divided by 0. You just can't divide by 0. So C cannot be 0 when it's in the denominator. And then number 5, it's going to be B over A. And then I need to throw in that constraint where A cannot be 0. Okay. So the getting started here, what that's leading us to is talking about slope in this lesson. And on this getting started, I'm going to scroll it back to the end of this lesson and talk about a little bit of your slope, talking about that. And then since we don't have patty paper on us as you're watching this video, I'm going to go ahead and just kind of talk about question 2 and 3 here at the same time. So where we need to go to do that getting started is at the end of this lesson, where, a little bit further down the road, right here is where they're using this grid. So what we want to do then is create a line that is parallel to this AB right here. So I can do this nicely with my paper. To be parallel, I'm just going to do a translation. I'm going to slide it left, I can slide it up, I can slide it to the right, I can slide it down. But what I'm trying to show here is as I slide this left and maybe up, okay, just as my example, what we're trying to get you guys to remember is the slope. On AB, we know how to calculate slope. Slope is rise over run. Or as you also could remember how to calculate it, the formula right here. So for AB, my rise, my run, I went up 2, I went to the right 1. So for the slope of AB, it is 2 to 1, or just 2. On the one that I translated, I'm going to call that XY, it is going to give you the same slope, because that translation is going to preserve the orientation of that segment. So for XY, our slope is also going to be 2. So what we're going to be finding out today is no matter how you translate that line, parallel lines have the same slope. And that's what I want you to take away from this getting started. Okay, parallel lines have the same slope. Now, if I flip it back to that page, I'm going to go on to the next page. And the next page says, do the same thing for CD. But now I want to talk about perpendicular. So there is CD, and that slope at the moment, okay, when I do my rise or run, the slope for CD is I go up 1 and then over 2, okay, which is 1/2. But what I want to talk about here then is, okay, oops, I accidentally deleted that, is the perpendicular now for this. So I've got my line here, and I'm going to rotate this, try to rotate it, let me see if I can, 90 degrees. Now by doing that rotation of 90 degrees, what that's doing is creating me then a right angle. Now, I want to make sure that this is lining up nicely. And as I rotate that, I'm going to bring it right, or sorry, translate that now. It's still perpendicular, okay? But I've made it to where I can calculate the slope of that new line segment. I'll call it XY. And what I notice then is, if I calculate that slope, I'm going down 2 and to the right 1. So for that XY, down 2, right 1, I get -2. When I compare the slope of CD to my new one, XY, what I'm noticing then is this new thing today. Perpendicular lines have what we call a negative reciprocal slope. Now, instead of saying negative reciprocal, you also will hear me say opposite reciprocal. And that's what we're going to then use today, along with the parallel lines, to kind of do some work with slopes of parallel and